Alright, so from today's weekly contest, or I should say yesterday's weekly contest, the first problem, construct the minimum bitwise array 1. So we are given numbers array and we are asked to find answer vector which is essentially going to uh, satisfy this condition, which is answer of I or answer of I plus 1, whatever the value is of answer of I, that is what we need to find, such that its or with 1 incremented will give me nums of I, right? So that's the problem. Uh, well, there are a couple of ways to solve the problems. We can do brute force since the constraints are small, but if we try to solve this mentally as well, since in the question it's given that we need to minimize each value of answer of I. That's the main part of this problem, because that will guide me to think of in terms of bits that we have to obviously think, because we are given bit operations that we have to do to satisfy the condition. So we have to, uh, in some questions we might not require, but we should always try to use bit manipulation questions where we are applying bit operations, right? So here, if this is a question, then if I convert it into bits, right, so I iterate and I encounter one, sorry, the first element, that is 2. So that in bits is 1, 0. So now I want something in answer for this particular element corresponding to this particular element, such that answer of answer or of answer plus 1 will lead me to 2. Well, since we are talking in bits, I need to minimize answer, right? So if I change this bit, it's a 1. If I change it to 0 and now I increment 1 to it, that will become 0, 1, and I do a OR of it. What will I get? Well, I will get 1, but that is not equal to 2. Is there any other bit that we can convert back to 0 and then do this same thing? No, there is only one, and we did the operation on that. We were not able to get the particular value. Then we can say that there is no possible way but -1. Now let's do the same thing here. I encountered 3. That's 1, 1. I see I need to minimize answer. So I see, let's try to, because MSP is always the most significant bit, right? That's what MSP stands for. So here, if I try to set the MSP to 0 and let the others be as it is, and now if I increment 1, so this is 1, I increment 1, so I'll get 2. I do a OR, I get 1, 1, which is equal to 3. Hence, this next element will be 1, right? So 1, and so on and so forth. We can do that. So since you're talking in bits, uh, what's the maximum element that we are going to encounter? Let's see. That's 1000. So that's very less number of bits, right? 1000 is what? 10 to the power 3. 3 bits, 4 bits. So maximum 4 bits. No, my bad. What am I doing? Log 2000 will be what? 9. So 10 bits, maximum 10 bits. That's what we are going to have. So we can iterate to 10 through 10 bits. From the 10th bit, I will try to set it to 0, and if I cannot, then I'll try the next bit. If I cannot, I'll try the next bit. If I straight away go through the 10 bits and I still cannot set it to 0 and get the answer that I am wanting, then I can say that just put -1 and move forward. Alright, so let's start coding. I'll get my answer vector, iterate through nums. I will iterate through each element, so each bit. So it will be 10 bits max. So from 10 till 0, I minus minus, and for each bit I'll start from the MSB and try to set it to 0. If it is 1 only, then I can set it to 0. So I will check if it is 1 by ANDing it at that particular position with 1. If this is 1, then I will get the number by setting it, get the new number by setting this bit to 0. So n and all the numbers will be 1 and this particular bit will be 0. So a negation of 1 left shifted to by I times. And if this is x or x plus 1, be careful because there can be precedence problem here, because I think if you don't use brackets, then it will not evaluate correctly. If this is equal to n, then let's break and put the answer as well. So I will have a sub answer which will be -1 initially, and here it will be updated to sub answer of n, sorry, x, and I'll break and push into my answer this sub answer, and that's my answer. Let's return it. Let's see if this works. Time complexity will be O of n, because for each number there is only 10 bits of iteration, so O of n, of 10n, but that will be O of n. This exact same code will work for the second problem, just that here since the constraint is a little bit higher, 10 to the power 9, so I will have to iterate through 30 bits, because 10 to the power 9 will take up to 30 bits of representation, and the time complexity again would be the same, just 30. The third problem is a DP problem. Basically, we are given source string and a pattern string and target indices. Alright, and we are asked to find, we are asked to find the number of removals that we can make. So if target indices are the indices within source, and each index here represents that if we try to remove this, the pattern should exist inside source after the removal as a subsequence. So if I remove A, I can't form ABA a subsequence from this particular string. So I can't remove A. So next thing I cannot remove is B. So if I try to remove it, then I see that ABA can be formed, and hence that's a valid removal. And the second index will be this, so 0 into this, again I can form ABA subsequence. So in total, not in total, but the maximum removal that we could have gotten is 1, right? By maximum removal and total removal, there's a difference here. Maximum removal here means the maximum number of indexes that we can remove such that pattern still exists in subsequence, right? And that's what we need to maximize. So it's a DP problem. We can or we cannot remove an element, and whatever gives me the maximum answer will be my answer. So I will just return I'll pass source, I'll pass pattern, I'll pass target indices, and I'll pass the respective indices, so 0, 0, 0. So it'll return int. So here first parameter is source, second is pattern, third is vector of int, and the others are indexes. So let me uh, name it as S, P, and T. These are the indexes. So at this particular point, if I exhaust pattern, right? If I exhaust pattern, then what is going to be my answer? At whatever point of time my exhaust pattern, that is P, becomes equal to the pattern length, the remaining target indices that can be there within this based on the index at this particular point, they are all good to be used, right? Since I need to maximize the operations, I will try to use all of the other remaining target indices because I know that I have already formed the pattern, right? So if P, or the pattern index, if it's equal to pattern dot length, then I can return the remaining target indices, that is clear left. So minus T. If I have exhausted source and the pattern has still not over, then I can return int minimum or something very less because I need to maximize it, right? So source is equal to s dot length. If that is the case, sorry, length, then I return some minimum number. Now I'm at a position where source is within limits, pattern P index is within limits, and I want to remove or not remove a index in source which should be present in target indexes, right? If they are not present in target indices and they are equal to pattern, then I can just move both the indexes forward, right? So there can be a while loop. Int I is equal to, suppose int I is equal to source, sorry, s, and int j, or I don't even need to assign it, I can just do a while loop. While is less than s dot length and p is less than pattern dot length, while they both are within limits, I will check if this particular index is equal to the target index, because if it is equal, then here I have to make a decision, right? So I'll break out and make the decision. So basically I will check if they are equal, and there can be scenarios where this p can be out of bounds. So here, to keep it within limits, let's do a check of this. At this point I will break, so that after the while loop I can make the decision of removing it or not removing it. If that's not equal, then I can increase both S and P, or I can only increase S based on the condition that is source of S is equal to pattern of P. If they are equal, then I am good to include this in the pattern so that I can uh, you know uh, complete the pattern as soon as possible. So this will be S plus plus and P plus plus. Else just do S plus plus, because this is some element that is neither, this is some index that is neither in target index, and its value or its character is also not equal to pattern, so it's of no use. So, so at this point I'm going to make a decision. uh, yeah, int value 1, this will be value 1. uh, so I'm making a decision of removing it, right? So I'm adding one operation to my answer, and I'm calling this function again, but with what indexes? Well, source, pattern, and target indices will be as it is, and then SP and T. So since I'm removing it, which means I'm removing S index, so I'm doing S plus 1 so that I don't start from there again. I'm removing that index. I'm removing it, so I'm using this target indexes. So target index, so type T plus 1, and in between there is a P, which will remain P as it is, because I'm increasing it as much as I can, and that's pretty much it. Int value 2 will be not removing it, so source, let me copy this. This is the only difference, because we are still moving ahead. Since we are not removing it, we are not going to encounter it again, so I have to remove this, or I have to increment this, and these will be not incremented. Return max of value 1 or value 2. That's what we'll return, and that's it. Okay, pattern dot length. My bad, the spelling is wrong. Okay, s dot length, it should be source dot length, and there should be s, again source dot length. Yeah, this is it. Let's see. Okay, source. Okay, the law of spelling errors. Pattern, pattern, okay. Source pattern, target indices, S plus 1, PT plus 1. Okay, yeah, my bad. So at this point, I must have already exhausted P or S, right? So at this point itself, I can return uh, if I have, you know, exhausted T, if it's equal to uh, the target indexes of size. If this is already exhausted, then there's no point in moving forward. I will check if I have my pattern also exhausted. If it is, then I can return 0, otherwise I can return int minimum, right? Because uh, I have not exhausted P, but I've exhausted target indices. So I can't really, since I can not even form a pattern in the first place, so there's no point in removing further indexes since there is no subsequence that is a pattern. So P is equal to pattern dot length. If it is, then return 0. If not, then return int minimum. Right, this works, but this will give us TLE since we need to memoize it. So this is going to give us TLE, and we can memoize it using a 2D array of containing state S and P, because S is going to be much more than T, right? And T is always going to be within S, so only 2D array is required. Uh, the max length will be 3001 because that's the upper limit for the 3000 is the upper limit for the length of S and P, and initially the value will be -1. So I'll do an mset dp comma -1 comma size of dp. Since I've declared it outside, I don't need to pass it here. Before making the decision, I will check if it's within my cache. If it is not, then I will if it's not, then I will initialize it before returning. Let's see if this works. The two states is going to make the time complexity of n square and space complexity as well of n square. And the better approach is obviously alright. So uh, this is not very optimal, but the better approach will be to go for the bottom up approach. But this is more intuitive in my opinion, and that's the three problem.